Hi, I'm Gibran Contreras and I'm going to talk about the process of building my Arduino. Well, the process was a little bit complicated, but not so much because I have a little experience in things like Legos or assemble things or just assemble things like toys or other things. To assemble it, I followed the instructions that you gave us. I put the motors on the platform, the tires, also the electrical components, and the cables. I made the connections where I used a soldering iron to join cables, and I burned my finger just a little bit, but it hurts. But in the end, it was pretty good. Although the code did not want to run on my computer, despite the fact that I followed all the steps and download the Arduino and run the code, but it doesn't want to run. So, but at the end, it looks pretty good and it's really great and what was a really good experience to build it, assemble it, and it was pretty cool.
Okay, so now it's my turn and I'm gonna talk about the components of the Arduino. So first I'm gonna talk about the DC motor. So this motor is a machine that transforms electric energy into mechanical energy in form of rotation. So this movement is produced by the physical behavior of electromagnetism. And as we know, DC motors have inductors inside which produce the magnetic field used to generate movement. We also have servo motors, and this type of motor is a rotary actuator or linear actuator that is in charge of allow to for precise control or of angular or linear position, velocity and acceleration. It consists of a suitable motor coupled to a sensor for position feedback. Servo motors are used in applications such as robotics, CNC machinery, or automated manufacturing. In our Arduino car we can see the ultrasonic sensors, and this type of sensors are in charge of working by emitting sound waves at a frequency too high for humans to hear. So when they wait for the sound to be, they use it to reflect it back, calculating distance based on the time required. This is similar to how radar measures the time it takes a radio wave to return after hitting an object. So we can see that all these type of motors have a lot of uses. For example, in real life we can see the DC motors like in tools and toys. They have a lot of appliances. For example, the universal motor can operate on direct current but is a lightweight brushed motor used for portable power tools and appliances, since the larger DC motors are currently used in propulsion of electric vehicles, elevator and hoists, and for example in drives for steel rolling mills. The servo motors have been around for a long time and are utilized in many applications. As I am telling you, they are small in size, but they pack a big punch and are very energy efficient. These features allow them to be used to operate remote controlled or radio controlled toy cars, robots and airplanes. So servo motors are also used in industrial applications as robotics, in-line manufacturing, pharmaceutics and food services. But how do they little guys work? Well, the servo circuitry is built right inside the motor unit and has a positionable shaft. The motor is controlled with an electric signal which determines the amount of movement of the shaft. Finally, I'm going to talk about the ultrasonic sensors. They are used around the world, indoors and outdoors, in the harshest conditions. for a variety of applications. So let's see them. Certain variables such as target surface angle, changes in temperature and humidity, and for example reflective surface roughness can affect the operation of this kind of sensors. These sensors are used primarily as proximity sensors. They can be found in automobile, self-parking technology, and anti-collision safety systems. The ultrasonic sensors are also used in robotic obstacle detection systems, as well as manufacturing technology. So they are used in robotic obstacle detection systems, as we can see in our Arduino. Now let's talk about the code.
What the code does is give the Arduino movement, makes its components do what it has to do with the specific commands for all its components. In this case, it makes the Arduino move and with the proximity sensor, and when it detects something, take another direction to follow and move around the things.
Now it's time to see our conclusion about this final challenge.
The teamwork was undoubtedly something very important. Me and my partner of the team, Alan Guerra, we divided the task to each other, what we did better, which one did better, and the final product was really good. And I think it's pretty good to work in team because it's more easy and you make social connections. It's pretty good.
So finally, I think that this project was very cool. I am a little bit sad because I don't have my Arduino, and I would like to make this project because it seems like it's very cool, and the function that has this car is awesome. I think that is like one of the best final projects that I have ever done. I also think that teamwork is perfect because we can complement each other, and although I do not have the Arduino physically with me, but I can contribute in another way, and that is the important thing. Also improve the sociability that we have with our partner or friend. So, in this project, we were able to put into practice everything we saw throughout the semester. We realized the importance of knowing the meaning of the function of each component that exists and how to put it together virtually so that we can later make it happen. And we also saw that the codes are extremely important to be able to control our robot and give the orders of what we want to achieve.